I'm going to try to make this video relatively short, so I'm going to go through these 5 word problems in hopefully about 5 minutes. Here's the first problem. James lives 3 and 4200 kilometers from school. Megan lives 7600 kilometers from school. The distance James lives from school is how many times as long as the distance Megan lives from school? So we're trying to figure out how many times as big is this compared to this. So to figure that out, we got to figure out how many of these 7600ths go into 3 and 4200ths, and we'll figure out how many times this is compared to this. So to write that problem out, it's going to look like this. 0.76 going into 3.4200ths. Now this is how we set up that problem to figure out the answer. And as we learned from previous videos, we just got to shift both decimals 2 times. 1, 2. So that's a whole number now. 1, 2. And I like to rewrite the problem so it looks normal. 76 going into 342. And if you did this, you'll figure out how many times further James's house is from Megan's house. All right, next problem. New habitats for 182 monkeys are being built at the zoo. Each habitat will house 8 or fewer monkeys. What is the least number of habitats the zoo will need? Explain what you need to do with the remainder. So we have 182 monkeys, and we can fit as many as 8 monkeys in each habitat. So the more monkeys we put in a habitat, the less habitats we're going to need. So we want to try to see if we can figure out how many monkeys we can put in habitats of 8. So we're going to do 8 going into 182. So 182 divided by 8, which looks like this. Now we're doing 182 divided by 8. Now I'm going to actually do this problem for you so you can see. So 8 goes into 18 2 times. Multiply 8 times 2 is 16. Subtract that. We get 2. Bring down my other 2, and we have 22. 8 goes into 22, again 2 times. This gives us 16. And then we have 6. Now remember, this 182 stood for monkeys. Now we have 6 monkeys left over. So you could say, oh, it's a remainder of 6. But the problem is we can't just leave 6 monkeys living in the wild. They need a habitat as well. So right now we have 22 habitats plus 6 more monkeys who don't have a habitat. So let's just give these 6 monkeys a habitat. So we've had 22 plus 1 more habitat, we'd have 23 habitats altogether. So on that problem, the answer would be 23. For the remainder, we had to use that remainder to make our answer go 1 higher, so those monkeys right there could have a place to stay. All right, next problem. A farmer ships 4 times as many oranges as tangerines. If the farmer ships 8,260 oranges, how many tangerines does he ship? Write an equation, then solve. So 4 times as many oranges as tangerines. So that's how many oranges he ships, and that's 4 times as much as the tangerines. So the tangerines are only 1/4 of that. So if we took this number divided by 4, we'd figure out the tangerine. So the equation would be 8,260 divided by 4, or in long division, 4 going into 8,260. So we're dividing this number by 4 to figure out how many tangerines. So then we would do the math there, and then we would be able to solve that problem right there. And I'll let you guys do the math in that problem, because I know you can do the math in that problem. Next problem. Jamal bought postcards of Washington, D.C. for $10.20, not including tax. If each postcard cost 85 cents, we write that as a decimal that way, 0 and 85 hundredths, how many postcards did Jamal buy? So 85 cents for 1 postcard. So we're trying to figure out how many 85s are in 1020. So we would still write it like this. Remember, since we're doing money, this is how we write 85 cents into $10.20. To make it, we had to make our divisor a whole number. Always make our divisor a whole number. So we got to shift this decimal 2 times to make it a whole number to go right there. If we shift our divisor 2 times, we got to shift our dividend 2 times. 1, 2 to go right there. Now I like to rewrite it so it looks nice and neat, which would be 85. We don't need that front 0. It means nothing. into 1,020. And now we do the math. We figure out how many stamps did he get with that $10.20 that he had. And each stamp cost 85 cents. And let's go to our last and final problem. Mr. Adams divides 223 markers equally among the 26 students in his class. He puts the extra markers in a box. What is the number of markers he put in the box? So now we got to figure out what we're trying to solve. We're trying to figure out how many markers he put in the box that were extra. So let's first figure out how many markers did those 26 kids get. So 223 markers, 26 kids are dividing them. So 26 into 223. I'm going to actually solve this one for you, so as long as you're watching this video, you get this problem. So I'm going to guess that 26 goes into 223 probably about 8 times. So I'm just going to guess and check and see how close I am. 26 times 8. The reason I guessed that number, I thought that this was about 25. 25 would go into 223 8 times. You could have done another strategy. So 6 times 8 is 48. And by 4. 8 times 2 is 16 plus 4 is 20. And that's going to be perfect, because I know if I had another 26 to that, it's going to be too high. So I have 8, and then I minus my 208. And I got to borrow. And that gives me 5, and that gives me 15. I have a remainder of 15. So what I know right now is I had 223 markers to share between 26 kids. Each kid will now have 8 markers, and there's 15 markers we can't share evenly. 26 kids, 15 markers, we just can't share those evenly. So my question, if I go back to it again, says, Mr. Adams divides 223 markers equally among the 26 students in his class. He puts the extra markers in a box. What is the number of markers he puts in the box? So all those extra markers we couldn't share that went in the box, we got to know what that number is. That's our remainder. So the answer to this problem would be 15. He put 15 markers in a box that he couldn't share. So this isn't our answer this time. Our answer this time is actually remainder. So hopefully this helps you out. 5 problems in 7 minutes and 30 seconds. If you have additional questions or problems, you know you can see me, email me, or ask me in class. All right, good luck to you.